If you don't mind, let's just skip the usual. Hello, my name's Jeff. I work for Laracon. So let's skip all that stuff. What's really important, I thought long and hard about what you guys want. I run Laracon. I see tons of tweets. I see tons of comments. Every video I post, the same question pops up. So I know what you want. What you really care about is an in-depth analysis of which color theme I use. You keep, you keep asking. You're going to get 45 minutes of it nonstop. Let's begin with the primary color. No, I'm just kidding. But I did think long and hard about what I wanted to talk about. I took a year off. My wife and I had a baby last year. So I wanted to get back into it. It stresses me out, but I'm always happy when I've done it. So I thought long and hard about what to talk about. And it was originally going to be called, pardon my French, but it was originally going to be called all the stupid shit I've done. And it was going to go since the beginning of my career and just talk about all the dumb crap I've done, honestly leading up to like stuff I did 2 months ago. But it was going to have tons of code examples, and hopefully it was going to be humorous, and you would have learned a bit. Might have been cool. This is not... OK. I'm not going to touch it. It's going to work. But anyways, I thought it would be educational, but I chickened out. I'm telling you, this is my nightmare. Are we good? You take it out and plug it back in again? This is what I tell every customer. Are we kidding? OK. We will not touch it. It will be fine. Anyways, I'm not going to do that talk, but I will tell you one story that I think is kind of funny. So it's my most embarrassing moment and also my most educational moment. You might have heard me talk about it on a podcast before. So one of the first projects I took on was a subscription site, and this was a very, very long time ago. So it was actually kind of an innovative thing. It's very, very common. It's almost a cliche at this point. But back then, not many people were doing it. Services like Stripe didn't exist. It wasn't that easy. But that's the best of it. So I created a site that would allow aspiring songwriters to send in their songs, and you would get actual professional songwriters to listen to them and review it. Turns out it's a good idea because lots of sites were actually doing it at this point. But the idea was good, and it went really, really badly. Because the thing is, way back then, I didn't know anything. Like, I knew HTML and a little CSS, and then this job comes up. I'm working for a client. This isn't just my own idea. And I was like, sure, I can do that. But no, I could not, as it turns out. So I'm going to tell you, when you're accepting credit cards and subscriptions, there's a lot of things you got to know. And among those, I did not know what SSL was. I didn't know what HTTP, I can't even say it right now, HTTPS, no idea. I had no idea what encryption was. I had no idea what hashing was. So how on earth am I going to accept credit cards with all of this way back then when all of these abstractions and services didn't exist? The answer is, when the user signs up and they enter their credit card number, I just send it in clear text to the server, and we throw it in the database, because I didn't know that that was a bad thing. I had no idea. So I literally had a database table full of credit card numbers, no encryption, no nothing. I should be in jail right now. Now, you're probably thinking at this point, Jeff, if you're so stupid that you didn't know how to hash and encrypt, how on earth did you figure out the billing, the automatic billing? And once again, the answer is, I did not do automatic billing. Here's what I did. I had a task set for every day, not a programmatic task, but like a piece of paper. Jeffrey, check every single subscription that's due for renewal, pick up the phone, call the credit card billing company, and charge them manually for $20 or whatever it happened to be. So seriously, I should be in jail for that. Luckily, only like 50 people signed up, and I was OK. But it did turn out to be incredibly educational for me. And I promise, if you're signed up with Laracon, you're good, OK? Your credit card numbers are nowhere to be found. So anyways, I chickened out. I wasn't going to tell you all the stupid crap I've done. Instead, why don't we get into the main talk? It's called Slay the Beast. TM, just for good measure. You can't be too careful these days. I run a very important one-person company, so do not take my trademark, OK? So anyways, we're going to talk about 9 considerations to get your app back on track. 9. Why 9? Why not 5? Why not 10? Why 15? As it turns out, Many of these things are very simple to explain. So if we're slaying the beast, I searched graphicriver.com for beasts. I found one that had exactly 9, so you're getting 9 tips today, okay? That's it. As it turns out, so often that ends up being why people make certain decisions. It's just like, oh, okay, let's do that. And then that's it. But I would say first, a word of caution before I get into some of these things. Yesterday, Adam used a DHH screenshot. He copied me, obviously, because I did it too. Take a look at this. 2012. It's like we have a Java Enterprise Edition Renaissance fair going on at the moment, digging up every discredited pattern of complexity to do a reunion tour. So as it turns out, this was a very, like every single thing the guy says, a very, very inflammatory thing. It offended a ton of people. And what you have to know is back in 2012, many of the conversations in the PHP community were having in 2017, they were having those exact conversations a half-decade ago. So it's something very interesting to keep in mind. So I would say for my talk, for every single suggestion, the key is to understand you try it out. If it made the code better, awesome. If it didn't get better, revert it immediately. There are no rules, there are no laws, there are just ideas that you try out, and then you compare the results. And once again, if it didn't improve the code, revert that crap as quickly as you can, all right? So let's get started. Beast number 1. We'll start kind of simple and then work our way up. Stop asking. Okay, so too often we find ourselves in these situations where we ask objects about themselves. We're always doing this. Give me this, give me this, give me this, give me this. We're like control freaks. Instead, so common, this is basic OOP. Just tell the object what you need done. So I'll show you an example here. We have a thread subscription class here, maybe for like a forum. User and a thread relationship. So the user, of course, refers to the user who has subscribed to the thread, like they're subscribing to updates. And then we have a thread relationship, and of course, that is the thread to which the user is subscribing. Okay, great. So now, imagine we need to notify that relevant user that the thread has been updated in some way. How do we do it? Well, you could do something like this, where it's like, okay, thread subscription, get the user associated with it. Laravel has that notifiable trait automatically on user. So we're going to tell user to send a notify method, and then we'll new up a notification class, and then we got to give it the thread, so we'll tell thread subscription to give us our thread. And this is like, it's like being a control freak, where we keep saying, give me this, give me this. You don't do it, I'm going to do it, and I will take care of it, but you're just like you're a pack of data. Just give it to me, and I'm going to do the work. What if instead, just tell it what you need done? It's very, very simple. Now, this can offend some people, but we are simply exposing the behavior that a thread subscription can send notifications. An email class can expose the behavior that it can send. It's the same thing. So now, we can move that behavior onto a notify method, and then you'll notice one thing. If we go back, at the before option, we kept referencing that thread subscription variable. But then once we encapsulate it within the class, you can replace all of those variable names with the this keyword. And I feel like for my own projects, when I find that refactor where I can just change it all to this, I kind of know I'm on the right path. Very, very simple. And you can use that all over the place. So pros, improved your API because you're actually exposing what it can do, and better encapsulation. Cons, decide for yourself when it doesn't matter, and you're going to see this all over the place. Sometimes, I feel like this is a very important but difficult thing for programmers to appreciate, is sometimes it just doesn't freaking matter. And it's very hard to wrap that around your head based on what we learned. But sometimes it matters, and sometimes it just doesn't, okay? It's fine as it was. All right, let's move on to number 2, single-use traits or concerns. This is an inflammatory one. I've seen talks where people call this an Annie pattern. I'm not going to do that. I'm going to call it, shocker, I'm going to call it a choice you make for yourself, okay? And I would even say, at the very least, these can be stepping. I'm sorry, it was there. Anyways, at the very least, it could be a stepping stone towards something else. These always, people always talk about like, well, you're missing a refactor, you're missing a more important design decision. And it's like, great, I don't know what that is yet. In the meantime, this will clean things up a little bit. Okay. So let's consider a user class, OK? So we have, once again, this concept of subscriptions. And we throw it all into user. And this is the thing. Everything makes sense on the user class, right? It's like no matter what the question is, like, can a user subscribe to things? Yeah. User subscribe? Yep, let's throw it on user. Can a user register? Yep. So needless to say, like in every single project, user is the very first candidate for abuse. It becomes the first God object because literally everything makes sense on user. OK? So what if instead, let's go back to that. This is fine, but I want you to remember in real life, there's tons of methods, there's lots of data, and so often those subscription-specific methods aren't nicely connected. They're like spread out throughout the entire class because you added one method 2 years after the other method, and it's just never quite as clean as you want. So what if, just throw it into a trait. Even if, like traits allow for multi-inheritance, but even if you're not thinking that, I think this can be a useful thing. We're assigning a name to a piece of functionality. We hunted through a user. We found the things related to subscriptions. We assigned it a name. And that's going to be something I say throughout the presentation. You take something that's somewhat implicit, and you give it an actual name. So now on user, a user has subscriptions. I think it reads very nicely. And like I said, it may be true that there's some other design decision you're missing here, and that's OK. You may not know what it is right now, but at the very least, I think you're cleaning your room. Now, other people would say, no, Jeff, you're just sweeping this crap under the rug. And you guys laughing agree with that. I wouldn't call it sweeping it under the rug. You know what I would think of it? You have a dresser, and right now all of your clothing is in a single drawer. And now we're just taking the socks out and we're moving it to a drawer. We're moving the shirts to another drawer. So I feel like you are tidying your space at the very least. And I get it, once again. Maybe the proper place for the shirts is on hangers in the closet, and you just didn't do that proper design decision. And that's OK. It's OK. It's OK for now. A key thing is that this isn't some huge change here. We're still optimizing for deletability. So if we decide later that that's not a good place for it, fine. Just delete the code and move it where it belongs. No problem there. So I don't think, like, there's no shaming necessary. We don't need to tell people that's not when you use this trait and you're violating the entire No, it's fine. It's fine. So pros. Helps better classify our code. And once again, it assigns a readable name to a thing. Helps us discover. It can be a stepping stone to discover new concepts. And then, of course, it does open the door for reusability, because very possibly other things in your application can have subscriptions that you can subscribe to. Now, cons, there are some considerable ones here. So when you extract a trait, yes, this Karate Kid is so much worse than the original. Can I get an amen? The original was so good, at least for my 10-year-old self. This one was a big letdown. Anyways, I lost my train of thought. OK, so the cons are, let's imagine you extract that trait and you're using Sublime Text. Well, now when you hit that keystroke to view all of the symbols in the class, it's not going to pop up anymore. OK? And I would say this is a significant downside, because unless you're intimate with the actual project you're working on and you just instinctually know where everything is, if you're coming to that project for the first time, it's actually really annoying. Because you go to the class, you know the method is there, you search for the symbol, it doesn't pop up. So then it's like, OK, let's go to the traits. Maybe it's in that one. Nope, maybe it's it can be confusing. If you use an IDE like PHP Storm, completely a non-issue. So I would say there are situations where you would definitely not want to use this approach, and I think that's perfectly fair. And then the junk drawer argument, there's some validity to it. It's fair. We all have to make up these decisions on a case-by-case basis. OK, next beast. Give it a name. We're going to stick with users. OK, so class user. Imagine you have the registration methods on there. You have the subscription methods. And now you have these other 4 ones in there. And I guess these are like related to like stats or something. So completions count. That gives you the number. If you think of something like Laracon, OK, you're going to get the number of completions. You're going to get the number of watch laters, the number of favorites, the number of experience. And once again, these are littered throughout the entire user class. So it's kind of hard to tell. And we're trying to think, OK, and there might be even more than this. So we're just going to stick with the 4. So you're thinking, like, what could we do to fix this? Now, here's one technique I really like to use. You find repeated suffixes or prefixes. So notice count, points is basically count. So we're finding this repeated suffix over and over. Now, I would say many times that's an indication that you might be missing something. So what does it represent? The count of this, the count of that, the points. kind of like stats, right? This represents the user's stats. So why don't we just make that a thing in our application? We give it a name. OK, so now go to the second class down here, stats. We've taken those methods from user. We've thrown them into stats. And now if you think about it, the count suffix, like completions count, it's kind of redundant now because we have a stats class. So we can strip those off entirely. And this ends up being cleaner because you have a single point of entry for anything stats related. OK. Now, notice if you still want to access stats through the user, like if you want to say, give me the user's stats, well, then just have a stats method there. And within it, new up stats, and then user passes a reference to itself. This is kind of a cool pattern to get into. User passes a reference to itself to stats. And now if stats does need to call back to user to get anything it needs, it can do that. And then that would be our API. And I would say a key thing here is sometimes people do these refactorings because they're like, you're really worried about decoupling, so you're going to refactor, and you're going to use a factory class here, and then before you know it, you've ruined that clean API you have, all in the name of decoupling, which is important, but not at the expense of your API. So if you want that to work, you have to write the code to make that work. And I would say the API takes precedence always. That would be my rule of thumb. Nothing is more important than that. And if you don't optimize for that, nobody's going to use your API. They're going to find something else that's easier to use. OK, so the pros, once again, we're discovering a new concept. We have this idea of stats that did not exist before. We retain a nice user-friendly API. Yes, we're newing up if we go back. We're newing up stats within user, and that's fine. I don't know what happened, but at some point, PHP developers were told you're not allowed to ever new up a class anywhere. It has to be a factory. And it's like, no, it's fine. Perfectly testable. No issue there whatsoever. Anyways, and it also helps us clean up a God object. Now, cons, once again, maybe you're missing something. So like we have that stats class, but maybe you're storing that in Redis, or maybe you store stats in a table itself, and it can be an eloquent model instead. That maybe you update a table every hour or something. It doesn't matter. Maybe there's some other refactor you're missing, and that's OK. You can refactor toward that when you find something that feels better for you. OK, let's talk about view polymorphism. Polymorphism, programmers love complex words. And if you know what this means, well, great, but you didn't know what it meant through most of your learning, right? Don't lie. You didn't know what that meant, OK? I love Neil deGrasse Tyson talks about, like, they have sunspots or black holes, very, very simple terms to describe things that are so much more complex than we will ever experience. But programmers, we will reach for the most complex term every damn time. So let's just break this down. What it means. And breaking it, I would love to take credit for breaking it down this way, but I saw a guy on Reddit do it, and I thought, that's a really nice way to explain this. OK, so poly and morph. So of course, poly means many, to have many sides, like a polygon has many sides. Morph means to change forms, right? So that means, polymorphism means basically to have many forms, OK? From the context of code, maybe it's a single contract with multiple implementations. I mean, that's kind of it at its core. Now, a cool thing about polymorphism, though, is the idea that the code that consumes this contract doesn't and shouldn't care about which implementation is used. It's irrelevant. If it sends a message, it should even be OK if you pass like a null implementation to it where it literally does nothing or it logs it. It doesn't care how it's handled. It just needs to know that it can send that message. So you can enforce this if you want. You can use you can type an interface if you want. Cool. You can use duck typing. It doesn't matter whatsoever. So view polymorphism, though, like how does that work? So imagine we're going to handle the blade, the view-specific process of rendering an activity feed. So think of it like a profile page, and we're going to see all the different activities that the user took, like the user subscribed to a thread. They created a thread. They responded here. They favorited this. They followed somebody. If you want to represent that as an activity feed, how exactly do you display that in your HTML? OK, well, maybe you have like an activities table, and you filter through it. And for each one, you're like, OK, well, if the activity type is created thread, here's the HTML. I want to use this icon, blah, blah, blah. But if it's another thing, then I'm going to use that HTML, and so on and so forth. And as you can imagine, you have like an n+1 problem here where every time you introduce a new activity type. Well, you got to come back here, add a new conditional, add more HTML, and it just gets gross. And before you know it, you might have like 15 different else-if sections here. So once again, if this is basic, if you only have a few, I think it's fine. Keep it simple. But if you start feeling that grossness and you want to refactor, then what can we do? So once again, pay close attention to lengthy conditionals that are starting to make you feel gross. It might be a sign of a refactor. So we're going to use polymorphism here in our views. So we know poly means many. Morph means to change form, so we're going to have different forms. Well, what if we just did something like this, where we say, activity type can be created thread, created reply, blah, blah, blah. Let's just make that a partial, and we're going to include that dynamically for each activity type. So now, I could create a partial called created thread, and now all of that's going to go in there. And then when I introduce a new activity type into my app, I create the partial, and it's all just magically going to work, and I don't have to return to that long if-else condition, introduce a bug or something. This can be a clean way to go. So now we're able to take something like this, which just feels bad, and we just turn it into something like this. And once again, we've assigned a name to each of those activity types, so if you do need to change it, it's very easy to quickly Command P to that file and make your change. So pros to this approach. It vastly simplifies lengthy conditionals, okay? That would include switch statements, of course. And once again, it assigns a name to an important piece of HTML. Now the cons are, may not be necessary. Just it may not be a thing at all. You have an if, else if, who cares? It's fine. You only do that refactor if it feels gross. The grossness guides you toward that. And we'll talk about that more in a bit. OK, next one. Upgrade to first class. So imagine that we're tasked with inspecting a message from some kind of form request value, and we have to detect spam. OK, so we need to detect spam. Detect is the keyword. So this is a technique I learned from Sandy Metz, which I like. So it's like, OK, we found our method name, detect. So what would be the appropriate place for the method called detect to live? What are we detecting? Spam. OK, that sounds good. That's how we want. You can open up a new file and you can create a test for this, or just open a Scratch file and just write it out. How do I want to detect spam? Well, OK, spam detect, done. So we start scaffolding that out, right? So we create a spam class. We add a detect method. OK. So what specific things constitute spam? Now, these are going to be basic. This gets very, very complex. But just for the demo, I'm going to show you some basic ideas. So maybe one of them is, well, we want to detect a series of invalid keywords. Maybe those keywords are stored in a database. Maybe they're an array, like this demo. OK. So what we do is, this might be your first stab at it. So stop laughing. He's not better, I promise. We've tested this. I'm much better at Rocket League than him. Anyways, so we kind of recognize detecting invalid keywords is kind of an important thing. So we give it a name, and we did extract a protected method, and then we just filter through invalid keywords. If we found it, then blam. OK, very basic. Go with me, though. But then it's like, OK, well, another thing we got to do is like, I run a form. This is something that people do. It's like they want to get past the validation requirement, the required attribute where you have to type something in. That was worded really well, Jeffrey. Anyways, what they'll do is they'll just hold down T, submit, and then you get your spam, right? So maybe that's something you want to say, like, no, you can't do that. OK. Well, what we could do here is we're going to have another one. So we've given it another method name, detect key held down, and then the regular expression down there, just look for a key, then look for four or more of that, and then if you find that, then something's wrong. OK? But it's starting to feel gross. And think, like, what if, in real life, you're probably going to have like dozens of different things that constitute spam. And this is starting to feel gross already. And I want you to notice that invalid keywords property, it will only ever be used in a single method. And when you come across this, once again, sometimes it might be a refactor. It might be an indication that you're missing something, where it's like, OK, this property, it cares about this method. And then this property is exclusive to that method, and it just starts feeling gross. So how might we refactor? We felt the grossness. It's going to guide us towards a refactor. OK, well, let's think about this. Those were the two method names we created. And remember earlier when I said learn to spot common and repeated prefixes and suffixes? I see a repeated prefix here. And once again, in real life, there's probably 10 of those. OK, so here's a cool technique. when you find this, each of those methods wants to be called detect, right? But we needed to be more specific about what it was detecting. But still, like, it wants to be called detect. So what you can do is you take everything that comes after that verb, and then upgrade that to a class. So that means you would have a class called invalid keywords and a method called detect, and a class called key held down and a method called detect. So I would say a good rule of thumb is to seek out method names with the same prefix like a hawk. Okay, it might be an indication. So in this case, you just create a class called invalid keywords, and now that invalid keywords property we had earlier that was only relevant to that one method, well, now it can live here and everything makes sense. And it's perfectly easy to test as well. Key held down gets upgraded to a class, and then we call a method detect on it. This is very, very simple. So now how do we trigger these? Because before, we had that single class, but now we potentially have like five or more classes. So how do we trigger them? This is a nice approach. Store them in an array. So our spam class now changes to have an inspections property where you store each inspection type. And then on the main detect method, we filter through the inspections, resolve them out of the container, and we call detect. And now if at any point something fails, then we throw an exception, or there's actually a number of ways you can handle that. But yeah, very, very easy. Supports the open-close principle if you care about that quite a bit. Because now if I introduce a new inspection type, I just add a new item to that array, I create a brand new class, and everything just works flawlessly. It's very, very easy. So pros, cleaner, better support for OCP. Cons, may not be necessary. And for smaller stuff, keep it simple. We let the grossness guide us. I'm going to keep saying that. OK, next one, make it a rule. So we're detecting spam, right? And then maybe, like the threads controller, you create a new thread or something. But we're doing it down there, and this is starting to feel weird because like detecting spam is kind of like a validation step, but now it's split up into two different things, and it's not a big problem, but it kind of irks me a little bit. And yeah, we could turn it to a protected method, but I don't know, it just feels gross. So what would I rather do? Like, I wish it could just be a validation rule, and it would just work. I could reuse that on any value I want, any property, any form input. OK, well, let's make that work. In Laravel 5.5, like Taylor showed you yesterday, this is so easy. PHP Artisan, make me a new validation rule. We're going to call it spam free. Spam free, this is what you get when you run that command. It'll scaffold a class with an interface that has passes and message. So passes is return a Boolean. Are we good to go or not? Do anything you want there. You do a string check, you make an API call, anything you want. Message is going to be the error message that displays in the view if the validation fails. Clean, love it. OK, well, let's just resolve spam out of the container, or you can inject it, whatever you want. And then we call detect. That's then going to loop through all of those inspections that we had. And now those throw an exception, though, or probably some kind of like bound spam exception. We're just keeping it generic here. But yeah, we got to return a Boolean here, so we'll just catch the exception and return false, and then we'll have a message. OK, very simple. And now we can do that. And yes, we saved one line of code, and I think that makes a difference. It makes it much cleaner. And then when I have another controller and I have to detect spam, it'll just work out of the box. Small bit of work. So pros are we can merge our validation-specific logic. It helps simplify our controller a little bit. Cons are I can't think of any. I think that's a good win. All right, let's move on. Make an announcement. So we're going to talk about eventing. I have a kind of love-hate relationship with eventing. I feel like it can be really useful, and then there's like elements of nonditude to it. So let's talk about this. We're going to add a reply. So we have a store. It's just a simple domain, so we can easily understand this. We're going to add a reply. You hit the store method. So the first step is like, well, yeah, you got to validate. So validate whatever is necessary. But then you have to persist it. So we call an add reply method or something like that, whatever you want to do. And that's like the main logic. So it's like you have, for any operation like this, you have your core logic, and then you have your side effect logic. And this can be really difficult to figure out, like, what do I do about the side effect logic? So yes, you have your core thing of adding a reply to a thread, but all the other things, like you find out, oh, we have to notify every single person who is subscribed to this thread, and you don't know where to put it, so you're like, oh, just put it on the controller, or like, that's fine, let's move on. But then you find out like another thing that needs to take place. So it's like, OK, you have to scan the reply to see if anyone was mentioned. And if they were mentioned, we have to send them a notification and let them know, hey, so-and-so mentioned you. And then more and more happens. And before you know it, the tutorial you watched where it just had that validation and persistence turns into this really long method because you have to do 12 different things as side effects. So this can be a hard thing to figure out. And then, of course, we have to return a response of some sort. So one solution is just throw it into thread. So open up thread, add reply, just throw it in there, get out of there, be done with it. And yeah, the benefit is you get back to this. And I feel like in my controllers, when I can kind of get close to this, it feels good. So you have this pattern of like validate, persist, and then return a response. I feel like when I get close to that, it feels kind of good to me. But still, just throwing it all in thread might be okay. Once again, maybe it doesn't matter. But if you feel the grossness and you want to do something else, you might try eventing. And there's some good pros and some major cons to it, I would say. So replies controller, we liked this. So we wanted to keep that as much as we can, but we still want to allow for all of those side effects to take place, right? OK, so thread has an add reply. We persist it, and then we just dispatch an event. This might be new to you if you've never seen this syntax here. Before, you would do an event function, and then you would new up thread receive new reply. Well, on events now with Laravel, you have a dispatchable trait. So when you call : dispatch, behind the scenes, it's literally just going to use the event helper. So you can use whatever you want, whatever feels good to you. I just think that reads nicely. OK, so we fire an event, and now in our event service provider, we just register our listeners. And the way I like to name these is like a when-then syntax. So the key of the array there represents when. When a thread received a new reply, and then the array after it, the value, that corresponds to then. So when a thread receives a new reply, then notify mentioned users, and then notify the subscribers. Notice we're not using listener classes. We're not calling it handler. We're keeping it very, very simple and very clear. And that's how I like to use my event listeners. OK, so now you have a dedicated place at the very least to scan the reply for mentioned users. And you may not know this, actually. So you can say user notify to notify a single user. But sometimes you have a collection of users. So in those cases, you can just say notification send. You get a collection of users, and then you just reference it once. And that way, you don't have to do like all of these users for each one, call notify. So kind of useful. Pros to this approach: open, closed, approved. So once again, that's a good principle, right? Obviously. So if you can follow that, then that can be useful. Simplifies your controller, simplifies your model. These are really easy to test as well. The cons, just 3 here, and I think they are significant. It's harder to consume. And this is a battle we've all had to deal with, where you're constantly struggling with what is the easiest thing to take in and read, and 6 months from now, what will be the easiest thing to comprehend, versus like, feels gross, I'm going to abstract it, I'm going to move this here, and I'm going to fire an event, and I'm going to pick it up over there. And when you come back 6 months from now, you no longer just have like a little transaction statement that tells you everything that happened. Instead, you're like, OK, it adds a reply, it fires an event. Then what happens? Well, let's go to the event service provider. Then I go here. Then I go to this file. And it's like it becomes harder to debug. It becomes harder to consume. And many times, that's a decision you want to make because it does end up making the code cleaner. But it's a downside. And there are traces of nonditude. OK. So I would say this is my personal rule. Don't default to events. We refactor towards them. And this is something I like to apply, honestly, across the board. I once heard Zach Kitzmiller say, the simplest thing to get the job done every single time. And that's something, nope. That's something I really, really like. The idea of we're going to take the simplest approach we can do now. And because we are optimizing for simplicity, we're optimizing for deletability, if that's a word. When we do need to refactor and make a change, it's that much easier. Versus doing a very huge approach where you're anticipating things that will never actually happen. And then when you do have to change it, it's much more difficult. So we optimize for the simplest thing to get the job done. So I would never default to events. I would default to the easiest thing to get it to work. And then the grossness guides me towards a refactor. I call this PDD. PDD stands for pain-driven development. You might disagree, but this is what I like to do. I let the pain guide me towards the refactor. And I love this approach because I think it keeps you honest. You're not allowed to do any hand-wavy what-ifs here. You're not allowed because your rule, just like with TDD, the rule is get to green as quickly as you can. The same rule would apply here, at least the way I build my apps. OK. So next one, apply some decor. We're going to use decorators here. Once again, some benefits, some cons. Let's talk about it. Decorator's a confusing term, though. Once again, I'm sure it was a long time before you really understood what a decorator was. And the reason is because you know that thing when you're trying to figure out what it means and you go to Wikipedia and you're immediately overwhelmed by like, I don't know what any of this means. I'm a programmer for 10 years and I can't understand any of it. I swear sometimes it's like they want the most complex way to get the concept across for you when you really want to say, just break it down and just tell me what it means. So a decorator allows us to wrap extra behavior around a class. That's it. It doesn't have to be more complicated than that. You have this class. It does this. You want to stack on B so that it also does A and B. We can use a decorator. That's one approach that you could use. So let's go back to that original example here where we had a messy controller. So we wanted to refactor. We didn't want to throw it in thread. That felt a little off. We could use events. But another option, of course, would be to use a decorator here. So if we say that if you look at the bottom, when a thread adds a reply, yes, it should do the persistence, but it also needs to do all of these other things, one or two other things. You could use a decorator to represent each of those other things. And now it becomes a little more cumbersome to instantiate, but the benefit is you get to compose that series of actions. And you can, almost like puzzle pieces, you can say like here, I want to add the reply, I want to do the social media notification, then I want to do this. Or you can strip one of those out. Because that is one issue. If you fire the event or you throw all of that logic within the thread class, well, now you've lost the ability to just add a reply to thread without doing all of these other things. And sometimes you just want to quickly add a reply to thread for the purposes of test or whatever it happens to be. So one benefit to the decorator is we can selectively do these things. So a decorator, once again, we're going to keep it simple here. Now, if you go to Wikipedia, like kind of like the official way is you're going to see like an interface that represents the decorator, and then this class will implement that interface, and then it'll type it. And I feel like that's one, like that can be fine and useful, but it's hard to learn what a decorator is when you have so many different pieces. Here's how I would say it. Your decorator and its constructor can accept the original implementation, thread, or can also accept a decorator, another decorator. But for here, just it accepts the original implementation. It adopts the interface it needs to, so add reply in this case. It delegates, so this thread add reply, it delegates, and then it stacks on behavior. Okay? So accept the original implementation, conform to the interface, defer to the original implementation, or the other decorator that is calling. Because remember, the way it works with a decorator, you call the constructor's implementation, and then that may call the other constructor, and you kind of get this stacking layer. And then, of course, we stack on our additional behavior. And that's it. A decorator allows you to selectively compose. Now, I would say an important gotcha with this. Any underlying code that uses thread no longer has access to the original API, right? Because before you had a thread instance, but now you have a notifying thread instance. And that like selectively conformed to the interface of thread. But if you have things like, if you look at the bottom, like, OK, well, I just want to get the ID or the path. Well, you can't do that anymore, right? Because now you have a decorator. So this is something I learned from the Ruby community. They have something called simple delegator that they can use. And we can implement that pretty easily. We can migrate it over to our projects very easily. So let's just imagine this is what we want. You can't do this right now, but let's just imagine this is what we want. We're going to use a trait, and then we're going to stack on our behavior. Good. OK. But now if I say thread ID, I still want that to kind of defer to the underlying instance, right? So simple delegator, we just have a handful of magic methods here. Notice we have get, set, call, very simple stuff. So let's imagine you call thread ID, but thread is that decorator. OK, well, that means your get magic method will hit, of course. And we're going to say, OK, let's just go to the original implementation and call its ID field. And if its original implementation is another decorator, then it's going to loop again. And it's going to go to, ultimately, the original implementation to get the method, to set it, or to get the property, of course. So now this ends up working very easily. And it's relatively painless once you create that. So Good pros and good cons here. Pros, we can selectively compose. That can be very useful in many situations. And we can retain the same API using that little trick there. The cons can be cumbersome. It kind of sucks to build that stuff up. So like you're getting flexibility, but you're paying the price of like this kind of sucks to construct this every time. And I kind of think it violates keep it simple a little bit, but sometimes that's exactly what you do want because that is the simplest approach. OK, number 9, use a query object. We were talking about this on Twitter not too long ago, so I thought I'd include it here. A query object, just think of it as a wrapper around a query. Very, very simple. So don't even pay attention to this code. Just imagine for your own projects, like that one query that's super, super complex. You're having to call all these methods to build up. You have query scopes. It gets confusing. And you don't really know where to put it. You have it in the controller, but that grossness has crept up big time. You could create a query scope on the model, but then it's taking up all this space on your model, and it's taking up your vision. So every time, I feel like every method when you open up a class is fighting for your eyes. And it's like this, once you get that query working, you don't have to edit it that much. But it sucks that every time you open up the model, you would see that query scope immediately, and you don't really need to. But it's an option. You could do that. You could throw it on a repository, but then you have the same thing where it'll get jumbled up with all the other methods. So a third option is to use a query object. And once again, really, really simple stuff. It just wraps a database query. That's it. It's a class. So often these patterns boil down to like, oh, just create a class and do it there. Very, very simple. So we have a featured collections query here. And then we have a run method. That can be static. That can be non-static, whatever you want to do. And then just throw your query in there. That's it. Your eloquent query. That's fine. Just throw it in there, and you're done. And now when you come back to your controller, feature collections query run. And you never have to look at that file again until you need to make a change. So that can be very useful and, of course, reusable. Now, I was talking to Dries about this actually not too long ago on Twitter, and he was saying that he uses invoke in these situations. So if you want to see, just for fun, like what that might be like, if you're not familiar with invoke, very likely you're not, invoke will be triggered automatically if you try to use the instance of a class as a function. Okay? So imagine you have a post class. You create a post variable that's a new post. If I then say post, open paren, close paren, we call it as a function. In that case, invoke will be triggered. OK, so what you could do there is if invoke contains that query, well, then you could type, sorry, Adam, don't get mad at me, Adam Weather, but you could type featured collections query. That will give you a new instance. And then if you just call that as a function, then you're going to get the exact same thing. Just for fun, whatever you want to do. Some people think that's cleaner. I'm OK with the run method. Honestly, it always sucks with run because you got to figure out, like, what do I call it? Is it fire? Is it run? Is it handle? Is it the dreaded process? So this gets rid of that, but it might be a little more foreign to people. So mostly it's for fun. Pros. So the main pro is we get to upgrade a confusing query to a first-class citizen. Once again, I keep writing that. You get to assign a name to an important piece of functionality. Super, super easy to test. You write a simple integration test, and you're done. Easiest thing in the world to test. You know, on that note, like I remember years ago when we were told that testing against the database was evil, that would have been really, really hard because we were told unit test everything. You don't do integration tests against the database. That's idiotic. And turns out, like, no. If you hit the database, some of these things, the only way to not hit the database is you start doing assertions against methods being called. Like, I expect order by to be called. And once you're in that, it's like, just give up. Like, you do not want to do that. It's horrible. You write a little integration test, easiest thing in the world to test. Cons, I would say, do not go crazy with these. So, like, if you adopt this and then suddenly you have 30 different query object classes, I feel like you missed something. So we always want to do that, the simplest approach technique, the simplest thing to get the job done, and then we refactor towards that. So in my own project, I have maybe a few, okay? A few for the really big things. All right, so in closing, we want to default to clarity, whatever direction that might be. If we do this refactor, did it improve clarity? If it did not, we revert, because it was more clear before. That's the key. And I would say, in general, like you want to fight for why any of these refactorings are important, because I don't care what people say, there is a cost to every time you create a new class or an interface or any of these things, there is a cost to it. And you want to measure that very, very carefully. So some themes here, don't try to impress. The job is not to like create a bunch of decorators because you've decoupled everything and now you can do this. And it's like, it doesn't matter if you ever would do that, but you have the ability to do it. And then you pat yourself on the back and you're good. And it's like, well, no, it's not necessarily better. You just added more files, but it's not like that necessarily made it better. So the key is not to impress here. The key is just to get the job done as cleanly as you can. And then, of course, for the 5th time, we let the grossness that you may feel, the thing in your gut where you're like, I don't want to. If you open a file around a coworker that you wrote and it makes you feel embarrassed, or you're like, I'm going to avoid that class because I don't want you to see this shit. If that's the case, like you let that grossness kind of guide you towards cleaning it up. And then, of course, revert when that refactor didn't actually work. OK, so I'm going to leave you with 2 quotes here, and then we'll finish up. One from Warren Buffett, believe it or not. I really, really love this. So, of course, Warren Buffett's one of the greatest investors of our lifetime. And I just came across this on Reddit or something. Somebody asked him, OK, I have $1 million saved up. What do I do with it? You know, he basically wanted steps. Like, what are these things I do to maximize this money? And then he just said, put it in an index fund and get back to work. I love this. I feel like there are so many parallels to the programming industry here. Like, think how many financial books and teachers would have taught him to do all of these. You're going to diversify. You're going to invest here and here and here. Nope. Can't allow it. But anyways, like, you could have complicated that through the roof, and then one of the greatest investors of our time just says, throw it in an index fund. And it's the exact advice that he offers his wife if he dies. I think that's incredibly important. If you think about programming, I love this quote. You can find a link at the bottom if you want to read more. You're not going to have much trouble reading those letters, so I'll make the slides available. But anyways, if you want a future-proof system, you don't want the T-1000 Terminator. You want South Park's Kennedy. So you need code that's easy and fun to kill. So I think this is important. And of course, you want to kill it as often as possible. And by optimizing for deletability, and you make this, it's so funny. We hear about changeability, and it's like, well, what if your code changes? You're going to need to set up the system in this way so that it supports changeability. And I feel like, I don't know about you guys, but so often when I've done that, it didn't help the changeability. When I did have to change the system, it really, really sucked to do that refactor because I had so much going on. But if we kind of stick to the fundamentals, we optimize for Kenny, as it says here, well, then when I do figure out new requirements and I understand the system better, changing it actually ends up being pretty simple. It's not that much to change. It's not that hard in a perfect world. That's all I got, guys. Thanks so much.